Hello and welcome back. And in this video, we are going to be looking at another very popular Google interview question, license key formatting. Okay, so let's go ahead and get started. Let's take a look at the problem itself first. So basically, problem reads that you are given a license key represented as a string S. So that's your input, which consists only alphanumeric characters and dashes. So all you need to be basically looking at is alphanumeric characters and dashes. Alright, so that's another point to keep in mind. The string is separated into n plus 1 groups by n dashes. So there could be like, n dashes. So, and there are n plus 1 groups. Alright. Now, given a number k, we would want to reformat the string such that each group contains exactly k characters. Okay, so what we need to do is basically, other than the string itself, we are also given a number k, an integer k, and we need to regroup these numbers, the license key alphanumeric characters, into that number of groups, the k number of groups. Okay, but still must contain at least one character. Okay, so except for the first all right, so let me read that. I read the part. Right, so let me highlight what we are reading. So we are reading this part: except for the first group, which could be shorter than k but still must contain at least one character. Furthermore, there must be a dash inserted between two groups, and all the lowercase letters should be converted to uppercase. Alright, so there are two important points here. The first one is except for the first group, which could be shorter than k. That means the very first group is going to have, if there are not enough numbers to form a group of k elements or k number of characters, then that only the first one, like the first group, is gonna be the one that's gonna have less than k characters. Okay, so what that means is basically when we are traversing, we should traverse from the backside, from the end of the string, because when we are actually filling all the numbers, if we traverse from the back, then eventually at the end, when even if we don't have enough number to form a group with k characters, it'll still be a group less than k characters, so it's gonna basically satisfy that condition. So that's a key we need to keep in mind, that we're gonna traverse from the end, not from the beginning. Okay, so that's one point. The other point is dashes must be inserted. So dash must be inserted between two groups. So we need to insert dash. That means any dash that have been inserted, we need to ignore those. So that's another good point that we need to keep in mind when we are working on the algorithm. All right, so now this part right here: given a non-empty string s and a number k, format the string according to the rules described above. Okay, so let's go ahead and take a look at the sample. So we have input s, which has this string 5f3z dash 2e 9 2e dash 9 dash w, and then k is 4. All right, and the output is 5f3z 2-2e 9w. So if you notice, all the dashes have been removed and all the lower characters are converted into upper case. Okay, so that's good. Then if we, and k is 4, that means, like, the group is gonna be 4 numbers. So if we go back to our theory of traversing from the back, we're gonna traverse w, ignore dash 9, ignore dash e, ignore there's no dash 2, So there's 2e9w, so that reached our k is equal to 4. So now we're gonna insert a dash here and then form the next number or the next group. Okay, all right, so that's the first example. And we were able to actually um, create a hypothesis that we are going to have to traverse from the back. Okay, let's go ahead and take a look at this example, because this is gonna be creating that situation where the first group has less than k number of characters in the last group, in the first group. Okay, so the string is 2-5g-3-j. Okay, k is 2. Okay, so we're gonna traverse from back. So j, ignore dash, 3, so j and 3. Now k is reached to 2, so we're gonna insert a dash. Okay, proceed. Then we have g, capitalize, and form a string, 5, form a string, dash. Okay, so basically this has reached 2, so we're gonna put a dash here. We're gonna ignore this dash, and then we have 2. Okay, so that's good. Now this is like, this proves that the traversal from the uh, tail, or from the length of the string, is gonna work better, because first group needs to have the k or lower number can have k or lower number of characters. Now if this question stated that last group can have, like, k or less number of less than k in the last group, then we would traverse from the beginning. Okay, so let's keep that in mind, and with that, let's go ahead and try the algorithm out. All right, so I'm going to pull up so we can whiteboard this. All right, okay, so we can still see our problem. That's good. All right, so first of all, we have this string. So let's take the second one, 2 5g, sorry, 5g, three j. Okay, so I guess first thing we need to do is we need to convert this string into uppercase, so we can make it 2-5g 3j. Okay, so that's gonna basically satisfy the requirement of having uppercase characters. All right, so that's one. Okay, now what we need to do is we need to traverse from the back of the string. So what we can do is we can take a counter I, or a pointer I, which is going to be the length of the string minus 1. So length is going to be 0, 1, 2, 3, 4, 5, 6, 7. So 8 is going to be the length, because we are indexing from, I'm just creating the index, so we can see how many indexes are there, and we're going to use this index for our traversal. But so the string length is 8, 1, 2, 3, 4, 5, 6, 7, 8 characters, so they're going to be 7 value for I pointer, which is basically essentially the length of string. Okay, so length of string minus 1, that will give us the last index. Okay, so the last index is going to be j, and I is going to point at j. Okay, so that's one thing. Second thing we need is a count which is going to be initialized to 0, and we're going to be monitoring this count to see if this count reaches equal to k. Okay, and whenever this count reaches k, we're gonna insert a dash between the string. Okay, So that's the next element that we're gonna need. We also gonna need a result, and this is gonna be a character array, and essentially this is gonna be an array that's gonna that we're gonna insert our characters in, okay, along with dashes and everything to form the new string. Okay. All right, I guess those are all the things that we need. Okay, so let's do one thing. Let me write it again here so we can perform our search or our traversal. Okay, so let's start with I as 7, count as 0, and result as empty. Okay, so I is pointing at here at j. Okay, and the conditions that we need to check is basically if this value of I, if the current value of I is equal to dash. Okay, so I is basically string at I is not equal to dash at this point, so we're gonna take that value and insert it into the result. Insert at index 0. Okay, and once we have inserted, we're gonna increment the count. So let me remove this guy, and let's choose different color so we know what's going on. Okay, so we have j that's inserted. Count is gonna increment to 1, and we're gonna decrement I to I by 1, so I is gonna be 6. So I is gonna be pointing here. Right now I is equal to dash. Okay, so whenever there is dash, all we need to do is move I to next element. Okay, so basically we're gonna decrement I to 5. There we go, I 5. By the way, k is 2 in this case. Okay, so and we're not gonna increment anything else. So we're not gonna increment c or put anything in r. Whenever we encounter dash, we are simply gonna decrement I and continue. Okay, so now I is pointing at 3, so we need 3, so we're gonna say 3j. Okay, so remember, we are inserting, we are not appending in the string, we are inserting at index 0. Okay, so so that's why it's 3j. Count becomes 2. All right, and then I becomes 4. Okay, so I is now pointing at dash once again. Okay, so now this is dash, so we're gonna decrement I to 3, so I is gonna point at g. Okay, now for the next iteration, when we are coming in, first we are checking for dash. Second thing, we are checking if our count is equal to k or not. Okay, so in this case our count is equal to k, so we are going to basically insert a dash. Okay, and we're gonna set our count to 0. All right, then we're gonna continue our loop forward. So or continue our loop, our I is still pointing at g at this point, right? So g is not a dash and c is not equal to k. Okay, so we reach to a condition where we are actually gonna insert the element. So we are going to insert g dash 3j. Okay, and we're gonna increment the count and decrement I. Okay, so I is pointing at I is pointing at 5 now. All right, so once again it's not dash, it's not equal, c is not equal to k, so we're gonna be inserting new value. So let's go ahead and insert 5g dash 3j. Okay, and we're gonna be incrementing c value, on decrementing I value. So I is going to be pointing at 1. Okay, now I is pointing at dash, so we're gonna simply decrement I one more time, and I is gonna point at 2. Okay, so we're gonna come back in the loop. I is not dash, pointing at dash, and C is equal K. Okay, so that means this condition is satisfied, so we're gonna insert a dash. So dash 5G dash 3J. Okay, and once we continue in the loop, we're gonna once again come back in the loop and say, okay, I is pointing at dash, no. I is, oh, we forgot to set this to 0. C is equal to K, no. Then we come to a condition where we insert, so we're gonna insert 2 dash 5G dash 3J. Okay, and we're gonna increment count to 1 and decrement I to 1, so it's going to be minus 1. Now when do we start our iteration? When I becomes smaller than 0. So we're going to run a while loop, which is going to be I is greater than equal to 0. So till that time we're going to run this. Okay, so hopefully this is clear. This is the concept that you're going to follow. So let's go ahead and write a function, and we're going to see this in more functional form. Okay, so license key takes a string and takes a key, returns a string. Okay, so first thing we're going to do is we're going to create a variable. Now in Swift we can simply convert our string into an array. So while converting string into an array, we can actually make it uppercase as well. So we are simply gonna call this variable array, and I'm gonna say array of s dot uppercase. Okay, so this is going to give us this step right here. So basically it's going to give all the uppercase characters. Okay, now we need a variable to track the count. Okay, so we're going to create a variable count and initialize that to 0. Okay, and we also need so we're gonna need I basically. So let's create I, and I is going to be array dot count minus 1. Okay, and that's going to be basically the length of the array minus 1. It's going to reach us to the last index. Then we are going to need a result, which is going to be an array of character. All right, so these are 4 variables I guess we're gonna need. Let's take a look. So we needed I, count, and result, and we have one more, which is array. Okay, so now we're gonna put our condition. So we're gonna say while I is greater than equal to 0. Now remember, we are actually decrementing value of I, so that's why we're gonna check for greater than equal to 0. Okay, and now we are going to first take the current value, so current character, into a variable, into a constant. So we're gonna say array at I, take that into a constant. That way we can actually, we don't have to write array at I every single time. Now we're going to perform our check. We're going to say if the current is, let me write it as current so we don't have to write the whole thing. Okay, if current is equal to a dash. Okay, so remember that was the first thing that we were checking right here. If it's equal to dash, so we are simply converting what we have discussed right here. We are converting that into an algorithm that's going to solve the problem. Okay, so if it's equal to dash, in that case we simply are going to say I minus 1. I is equal to I minus 1. Okay, and then we're gonna basically continue in the loop. So everything else is gonna go in else if. So else if. Now we need to basically find out if the count is equal k. Okay, so we're gonna use mod operator, but in order to use mod operator and compare it to 0, basically count could be 0 as well. So we're gonna simply say count is not equal to 0. Okay, so it doesn't go inside this for the first time, and count mod k is 0. Okay, so basically what this line means is, first of all, count is not equal to 0, and second thing is count mod k. So when the count value is 1, if you mod that by 2 in our example, for example, let's say 2, then the remainder is going to be 1. When the count is 2 mod 2, the remainder is going to be 0. Okay, so that is the difference. Basically what that we are looking for is basically when the count is divisible. So if the count reaches 4, for example, and if our value of k was 4, then we are going to reach 4 because 4 mod 4 is 0. Okay, so we know that we reached that count value. So that's when we need to actually insert a dash. So we're going to simply say result dot insert dash at 0. Okay, so we're gonna insert dash at 0 in this case. Okay, and we're not gonna increment or decrement anything. All we need to do is we need to make sure that we mark count or reset count to 0. Okay, that's gonna be the else if condition. Now else condition is gonna be basically when we have found a character. So when this condition is met, not met, this condition is not met, that means we are at a character. So we need to basically insert that character and increment count and decrement I. So the else condition is going to be first result dot insert that current at 0. Okay, and we're gonna say count is equal to count plus 1, and I is equal to I minus 1. Okay, so that's gonna be our loop. So this is gonna be end of while loop, and this is gonna be the end of else and else if and if condition else end. Okay, so basically we actually iterated over the entire string now. Okay, so now at the end what we're going to return is simply our string. So string format of result. Okay, and that is going to be the solution. All right. So this is basically going to be the algorithm. Once again, we are going to have a variable that is going to contain each character, uppercase character, um, into of the string into an array, and then we're gonna have a count variable that's gonna keep track of the value to compare with k, so we can insert dashes. Then we're gonna have I, which is gonna be the pointer that we're gonna iterate backwards, right? So we're gonna traverse our string backwards, and I is the pointer that we're gonna use to check if the pointer is pointing at dash or a character. Okay, then you're gonna have a result, which is gonna be the array of character that's going to be eventually returned in the form of a string, the final result of the license key formatting. Now we are going to run a while loop from back until I is greater than equal to 0. So if the I becomes negative value, -1, that's when we're gonna stop the while loop. Okay. First thing what we are doing is we are actually taking a character. So basically wherever the I is pointing at, we're gonna take that into current, so we don't have to write this array at I every single place. So we're gonna take that into a constant. We're gonna compare that constant to see the first condition. We're gonna check if I is currently pointing at dash. If I is currently pointing at dash, then we simply want to move forward. So basically we don't want to do any operation, we just want to move forward, so we're gonna decrement i's value. Okay, so we are decrementing i's value here. Now after that, let me take a different color so we know. Okay, so after that, so we have decremented. This loop is gonna continue, so none of the else conditions are gonna be executed, because if it's already executed, so it's going to go over into the next iteration. I's value is decremented now I is not pointing at dash anymore, so then next thing we check if if the count is not equal to 0 and count is divisible by k, right? So that means that if count mod k is equal to 0, that means we have reached our count to the given number k. So for example, k is 2, then if count is 2 and k is 2, that means we have reached that condition where we need to insert basically a dash. Okay, so we're gonna insert a dash at 0 index, and we're gonna reset our count to 0. Okay, so when that condition is executed, so loop is gonna continue back again, and then we're gonna come back again for the I value. Now I has not changed in this iteration when we found count to be equal to k, right? I has not changed, only count has changed, and count is now equal to 0, so this condition is not going to be satisfied. So it's gonna basically short circuit from here and go into the else condition. Now in this case, I is neither pointing at dash nor the count value is equal to k, so we're gonna basically insert a character into the result. We're gonna increment count value, and we're gonna decrement I value, and continue our loop. Okay, so like this we're gonna iterate over the entire string, and eventually our result is going to have basically the formatted license key, and we're gonna return that in the form of a string. Okay, so this is the program that we're gonna actually write to basically check our algorithm. Okay, so let's go ahead and hop on to Xcode, and we're gonna take a look at this problem by writing and testing, running against these two conditions that have been given by the LeetCode. Okay, so let me go ahead and pull up the Xcode. Alright, so I have Xcode pulled up, and this is what we have. We have a function that actually takes a string and k constant and returns a string. Okay, so let's go ahead and try out our algorithm that we created. So we're gonna first take our array and we're gonna say array s dot uppercase. So we're gonna get each individual character out into an array. We're also gonna create I, which is gonna be representing I dot array dot count minus 1, and then we're gonna have a count, which is gonna be keeping track of the dashes, when to put dashes, and result, that's going to be the array of character. Now we're gonna run our loop while I is still greater than equal to 0. Okay, and we're gonna return string result. Okay, now we're gonna take a current constant and we're gonna say array dot I, put that into the current constant, and now we're gonna say if current is pointing at dash. Okay, and it's already given in the question that the string only contains alphanumeric characters and dashes, so we don't have to worry about checking other characters. Okay, in that, if current is pointing at dash, then all we need to do is we need to say I minus 1, or to simplify this, you can say I minus equal 1. Okay, and we're going to continue from here. Now else condition is going to be if the count is not equal to 0 and count mod k is equal to 0. That means count has reached at a point where we want to insert a dash. So we're going to simply say result dot insert dash at 0. Okay, and that's it. We're not gonna decrement count. We actually need to reset the count to 0, but we're not gonna increment I or anything. Now last part, or last condition that we're gonna have to set is basically when I is pointing at a character. So we're gonna simply take the result and we're gonna say insert current at 0 I, so decrement I, so I minus equal 0, and increment count, so plus equal 1. Okay, and that is going to basically, so let's create this as a let, so warning goes away. So this is basically showing us that so this is the last condition, is showing us that when the I is pointing at a character, then we need to insert that character, decrement the value of I to 1, sorry about that, I by 1, and not I to 1, I by 1. So if it's 3, then it's gonna be 2. Okay, and increment the value of count by 1. So if it's 1, increment it to 2. Okay, so that's going to be the last set in the else statement that we can execute. Okay, so this is all of our algorithm that we wrote. So let's go ahead and execute it, and we're going to see if it works or not. So let's go ahead and write a driver. So I'm going to make this file private. Okay, and this driver program is basically going to call this, and it's going to print. So let's give it an array of input. So input is equal to, and let's see, let me take out the okay, so these are values that we are looking at. So we need this string, right here, and we need this string right here. Okay, so let's go back and let's not do this. Let's do this because case value. Otherwise, we'll have to we'll be creating dictionary. So I'll rather make it simple, super simple, and to print license key formatter. The string is going to be this one. The value of k is 4, and I'm gonna copy this and paste it, and gonna take this string and the value is going to be 2. Okay, so this is going to be our driver that's going to basically execute on these two strings with case value 4 and 2. So let's go ahead and try to execute this and see what we get. Alright, so let me go ahead and run this. Okay, so it's building, and there we go. Alright, so for the first string, if we look at, we are getting set of 4 and then a dash and set of 4. And for the next string, we are getting set of 2, 3j dash 5g dash 2. Okay, so we are satisfying all the conditions that we discussed during the problem. Basically, and our solution matches what we have in the output right here. So this is what we have. These two are solution, and we are satisfying all the condition. Even the last group can contain k or less than k elements. All right, so this is the solution to the problem, and once again, this is actually let's take a look. So capital 1 has been asking this question a lot, and it's been asked basically at Google. You can see like it's been asked at Google quite a lot, like 44 at least reported instances. Okay, so yeah, so this was the solution that we discussed for license key formatting. Hope you enjoyed the video. Thanks again for watching, and I will see you guys in next video.